Hello everyone, here we are going to continue with exercise 9b of the chapter triangles. We were doing the questions related to congruency of triangles in this exercise. We have already did till question number 14 in our previous video. Now let's start with question number 15. Now here in question 15 we are having this figure in which angle A equals to angle C and the side AB is equals to BC. Now we have to prove the triangle ABD is congruent to triangle CBE. So in triangle ABD and triangle CBE, we can take the angle A equals to angle C given, AB equals to BC again given, and this angle B will be common in both of the triangles. Then to prove these two triangles congruent, we have used this angle, this side and this angle. So the side is lying between the two angles, so it will be ASA. Therefore, triangle ABD is congruent to triangle CBE by ASA congruency criteria, hence proved. Now, in question number 16, from the information given in the question, we have got a line segment AB on which there is two equal perpendiculars DA and BC. Then we have to prove that line joining CD bisects AB in two equal parts. So we have taken this intersection point as O and we have to prove this AO equals to BO so that this CD may bisect this line AB. Now to prove this, we are going to prove these two triangles congruent. So in triangle DAO and triangle CBO, we can take DA equals to CB as given, angle A equals to angle B 90 degree each, and this angle will be equals to this one as vertically opposite angles. Therefore, angle AOD equals to angle BOC by vertically opposite angles. Now to prove these two triangles congruent, we have used this side, this angle and this angle. So it will be AAS. Therefore, we have got the triangle DAO is congruent to triangle CBO by AAS congruency criteria. Now we have to prove that AO equals to BO by CPCT. And here we got AO equals to BO by CPCT. Now as AO equals to BO, therefore the CD bisects the line AB into two equal parts. That implies CD bisects AB, hence proved. Now let's move to question number 17. Here we are having a figure in which we are having a triangle ABC in which AB is equals to AC. And there is a line BO and CO which are the bisectors of the angle B and C respectively. We have to prove this BO equals to CO. Then we have to prove this line AO bisects angle A. Now, very first of all, in triangle ABC, here we are having AB equals to AC. This means this angle as a whole will be equals to this angle as a whole as angles opposite to equal sides. So here AB equals to AC given and therefore angle ABC equals to angle ACB by angles opposite to equal sides. As angle ABC is equals to angle ACB, therefore the half of these two angles will also be equal. Therefore we can write this one over here as half of angle ABC equals to half of angle ACB. Now half of angle ABC and half of angle ACB can also be written as OBC and OCB, as OB is a bisector of angle B and OC is bisector of angle C. So here we get angle OBC equals to angle OCB, as OB and CB are bisectors of angle B and C respectively. And here we got angle OBC equals to angle OCB, as OB and OC are bisectors of angle B and C respectively. Now in triangle OBC we are having this angle equals to this one. Therefore this side will also be equals to this one as sides opposite to equal angle. Therefore BO equals to CO as the sides opposite to equal angles in triangle BOC. Now we have to prove this line AO bisects angle A. This means this angle is equals to this one. For that we are going to prove the triangle AOB as congruent to triangle AOC. So in triangle AOB and AOC we can take AB equals to AC given to us, then AO equals to A common and BO equals to CO proved above. Now to prove these two triangles congruent, we have used all the sides, this and this one. Therefore it is congruent by SSS criteria. And here we got triangle AOB congruent to triangle AOC by triple S. Then we can prove this angle equals to this one by CPCT, and we got angle BAO equals to angle CO by CPCT. Therefore this AO bisects angle BAC. That implies AO bisects angle BAC, hence proved. Now let's move to question number 18. Here we are having this figure. In this figure, we have been given with AB equals to FE, then BC equals to DE. Also, it has been given that B and E are 90 degree each. They are perpendicular to each other. Now we have to prove this AD equals to FC. For that, we are needed to prove the triangle ABD congruent to triangle FEC. Now to prove these two triangles congruent, we can use this side equals to this one as given. This angle equals to this one again given. But we have been given that BC equals to DE. But we need BD equals to EC. So to get this BD equals to EC, first of all, we are going to add the common portion of CD in both of the sides, BC as well as in ED. So here BC equals to DE given to us. And now we are going to add this common portion CD in both of the sides. And on adding CD in BC, it becomes BD, and CD in DE, it becomes EC. Therefore, BD equals to EC. Now we can take the triangle ABD and triangle FEC. Here we get AB equals to FE given, BD equals to EC proved above, and angle B equals to angle E as 90 degree each. Now to prove these two triangles congruent, we have used this side, this angle and this side. So it is SAS. Therefore, triangle ABD is congruent to triangle FEC by SAS congruency criteria. And AD will be equals to FC by CPCT. That implies AD equals to FC by CPCT. Hence, proved. Let's see question number 19. Here, as per the information given in the question, we have got the rhombus ABCD, and there is a point O which is equidistant from the vertices B and D. Now, we have to show this line AOC is a straight line. That is, we have to show the sum of these two adjacent angles is 180 degree. So that we may be able to prove the AOC is a linear pair. Now to do so, first of all, we are going to prove these two triangles congruent. So in triangle ADO and triangle ABO. Now here in triangle ADO and ABO, we can take AD equals to AB at the sides of rhombus. This AO equals to A common and DO equals to BO given. Now to prove these two triangles congruent, we have used all the sides, that is AD, DO and AO. So it is congruent by SSS criteria. Therefore, ADO is congruent to triangle ABO by SSS. Now we can prove these two angles equal by CPCT. Therefore, similarly in triangle CDO and COB, we get angle COD equals to angle COB. Now let these two relations be equation number 1 and equation number 2. As we know, the sum of all the four angles over here is 360 degree. Therefore, angle AOB plus angle AOD plus angle COD plus angle COB equals to 360 degree by the sum of angles at a point. Now, from equation number 1 and 2, we can replace angle AOB by AOD and COB by COD. Therefore, from equation number 1 and 2, we have got twice of angle AOD and twice of angle COD equals to 360 degree. Now we can divide the whole equation by 2 to get angle AOD plus angle COD equals to 180 degree. Now as the adjacent angles are having the sum of 180 degree, therefore this AOC is a straight line. So here as adjacent angles are having the sum of 180 degree, therefore AOC is a straight line. Now we'll move to question number 20. And here by the information given in the question, we have got this figure in which AD is equals to BC and this AC is equals to BD. Now we have to prove the angle ADB is equals to angle BCA and angle DAB equals to angle CBA. Now to prove these two, first of all, we have to prove the triangle ADB congruent to triangle BCA. So in triangle ADB and BCA, we can take AD equals to BC given, BD equals to AC again given, and AB equals to BA common. Now to prove these two triangles congruent, we have used all the three sides. Therefore, they are congruent by triple S. Therefore, triangle ADB is congruent to triangle BCA by SSS, and angle ADB is equals to angle BCA by CPCT, and also angle DAB is equals to angle CBA by CPCT. Hence, proved. That's all from this video. Thank you.